This entire AI-driven world we're living in, it all runs on these massive, power-hungry data centers. But what if we've been building them in completely the wrong place all along? Today, we're going to dive into one of the biggest, wildest technological bets of our time, moving our digital world into orbit. It's a plan that's either totally brilliant or brilliantly insane. Let's figure out which one it is. I want you to just look at this number for a second. 5 million gallons. I mean, that is a staggering amount of water. But what is it for? You might think it's rocket fuel or something, but the reality is a lot closer to home.
That's right, 5 million gallons of fresh water every single day, just to cool down one major data center. This is the massive, hidden environmental price tag of the AI boom, and it's a problem that is fundamentally stuck here on Earth.
And honestly, that insane water usage, it's just the tip of the iceberg. The reality is we are barreling towards a full-blown data crisis right here on the ground. The physical limits of our own planet are actually starting to put a cap on how far AI can go.
Now, you might look at this and think, okay, 1.5%, that's not so bad. But that number is exploding. Here's the crazy part. Some projections say data centers are going to make up nearly half of all new electricity demand in the US over the next few years. We are literally running out of juice for our AI ambitions.
So you see, it's not just one problem, it's this whole cascade of issues. Getting hooked up to the power grid is becoming a total nightmare. Local communities are saying, not in my backyard. And the money needed to keep building here on Earth, it's astronomical. We're talking up to $8 trillion by 2030. There has to be a better way, right?
And that better way might just be the most audacious, sci-fi sounding idea ever. The solution? Stop trying to fight against Earth's limitations and just leave them behind altogether. An orbital data center is pretty much exactly what it sounds like, a giant floating computer station in space. And the whole idea is to use the unique physics of being in orbit to solve those two huge problems we just talked about, getting enough power and getting rid of all that heat. And this right here shows you why the idea is so compelling, so elegant. In orbit, you get nonstop sunlight that's 40% more powerful than what hits the ground. And for cooling, forget water. You use the biggest, coldest heat sink you can possibly imagine, the near absolute zero vacuum of deep space. It's an incredible solution, powered by nothing more than pure physics. But listen, this isn't just some theory tucked away in a science journal. We're talking about the biggest names in tech, the people with the deepest pockets on the planet, and they are already placing their bets. This is a brand new space race, and the prize is basically the future of computing itself. And this isn't some far-off dream either. Just look at this timeline. This is happening right now. A company called StarCloud has already trained AI models in orbit. Google just announced its own moonshot, Project Suncatcher, and you've got multiple companies aiming for major launches in just the next couple of years. The momentum is just undeniable at this point. And the list of who's involved? It's a who's who of the new space economy. You've got the heavy hitters like Musk and Bezos, tech giants like Google, and even entire countries getting in the game. This has moved way beyond a fringe idea. It's a new frontier, both economically and geopolitically. Okay, so for all that brilliant physics and all the billionaire money, we have to face a pretty harsh reality. The idea is beautiful, but the economics and the engineering, oh man, they are brutally, brutally difficult. This is where the dream smacks right into the balance sheet. Here is the single biggest hurdle. Right now, it costs thousands of dollars just to get 1 kilogram into orbit. For this whole thing to make any financial sense, that cost has to plummet to under $200. The entire business model hinges on future rockets like SpaceX's Starship coming through with these incredible cost reductions. It's a massive bet on tech that isn't even proven at scale yet. And then there's the heat. So yeah, space is the perfect heat sink, but actually getting the heat out of the computers and into space is a monumental engineering challenge. A gigawatt-scale data center would need a radiator structure over a kilometer wide. A kilometer! We have never built anything even remotely that big in space. This is a fundamental problem of scale. And it doesn't stop there. You've got constant radiation just blasting the hardware, meaning you have to replace it every 5 years or so. The time delay, just the speed of light, makes them useless for some of the most valuable AI jobs. And get this, the real ironic twist is that some studies suggest that when you factor in all the rocket launches, these clean data centers could actually have a worse carbon footprint than the ones on Earth. And this quote from an expert really brings it all back down to earth. What he's saying is when you add up all the costs, the launch, the building, the maintenance, the insane risk, the math just doesn't work. Not yet, anyway. So, how are we supposed to think about this? Is it this revolutionary, once-in-a-lifetime opportunity? Or is it just a giant black hole for money? Let's break down what the investment landscape actually looks like.
This table really says it all. If you invest directly in a space data center startup today, you're making an extremely high-risk, high-reward bet. We're talking more than 10 years before you see a dime of profit, and there's a very real chance you lose everything. Now, the upside could be 100x, but it's basically a lottery ticket compared to safer bets like building more data centers on Earth or just investing in the AI chip companies that win no matter where the computers are.
So, if you're watching this industry, here are the key things to look for. Number one, launch costs. If they don't get under $500 a kilo, this dream is probably dead. Number two, watch those prototypes in 2027 from Google and the others. Do they actually work? And finally, keep an eye out for any big breakthroughs in radiator tech and see if the big cloud companies start putting more serious money on the table after these early tests. And last but not least, here are the big red flags. Be really careful about the hype around small prototypes. Training a tiny AI model on one computer in orbit is a cool demo, for sure, but it proves nothing about solving the gigawatt scale problem. Be super skeptical of companies with huge valuations based only on promises. And hey, don't forget that there are other wild, but maybe less risky ideas being tested right here on Earth, like sticking data centers at the bottom of the ocean. So, that leaves us with the trillion-dollar question. Are orbital data centers the inevitable next step for our digital world, a solution as bold and ambitious as AI itself? Or are they just an extravagant, incredibly expensive dream? The physics are beautiful, but the economics are still a long, long way from home. The answer, I think, will be written up there in the stars over the next decade.